In this video I'm going to go over running the ZX81 ROM on my ColecoVision computer. So I've got my ColecoVision computer here and the cartridge plugged in with a ColecoVision game Frogger on it, and I've got a ZX81 keyboard plugged into my ZX81 port, a ColecoVision controller plugged into controller 1, and an LCD display at the back to display everything. So when I first turn on, it's in ColecoVision mode, so I'll play the Frogger game just to show that it still runs the ColecoVision Frogger. So there's Frogger. I can start the game, and with the controller 1 I can control it. I can play the Frogger game. But I can switch over into ZX81 ROM. So it doesn't matter that the cartridge is still plugged in. It's now gone over to the ZX81 ROM on this switch, and I've got the ZX81 prompt on the screen. Now I have to take the joystick out of the controller port 1 because it's on the same port as the ZX81 keyboard, and because the ZX81 keyboard is actually on the ZX81 port for the keyboard, I should hopefully be able to get games playing on here. But I'll write a quick program to demonstrate the ZX81 ROM in action. I'll just display the character set as like the default kind of example program which I write. Oops. And I've got a just my test keyboard plugged in at the minute, just so that one that I don't mind knocking about. I've also got a keyboard which I've shown in the previous video where I talk about designing keyboards, and that's got the actual ZX81 legends on the keys. And also I've got like other keyboards for when I get CPM and other things like that running. Now if I run this test program, see, it displays the character set on the display and how fast that runs, because it's going through a Texas Instrument chip to display the display, whereas on the ZX81 the CPU did all the actual display updates of the actual each scan line. So because it's not having to do those scan line updates and the Texas Instrument display is taking all that load, it actually runs so much quicker than a standard ZX81 would run. I'll just edit that program and just do a quick sine wave program just to show the graphics of the ZX81 running. So so I edited line 10. I'll rewrite line 20 to do the plot. And if I can remember which the program is, and I've got my key card here just in case I forget any of the keys. It's A, and do a divide by 10 so that it shows a full sine wave, and then multiply by 21, and that should display a sine wave. Again, that runs so much quicker than if you ran the same program on the ZX81. So it's like it's running in fast mode all the time because it's not doing all the display update stuff. I'll just edit that program to do a tighter sine wave, just to do two lots of sine wave stuff. So there's the ZX81 ROM running on my ColecoVision computer. Now I've got to get ZX81 games running on the cartridges hopefully next. Then I'll try and get Jupiter Ace ROM running on my ColecoVision computer. Then I'll be able to program in Forth on this computer as well. And then ultimately I want to get CPM running on here as well, so I can do productivity software as well as this catalogue of games. So I'll go for the display driver code which I've written to display a ZX81 display memory onto a Texas Instrument display chip. So this is the routine in Z80 assembly language. And at the top here I've just got a little bit of code in here where I save the status of the registers, which checks to see if I'm already in the non-maskable interrupt routine, because the Texas Instrument chip on a ColecoVision uses non-maskable interrupt, whereas on something like an MSX machine it just uses a regular maskable interrupt. But as you can't mask the non-maskable interrupts, I've just got a bit of code in to say if I'm already in the non-maskable interrupt routine, then don't run it twice, just so that it doesn't get into like an infinite loop and run out of stack space and fall over. And then I've got a little bit of code here which is commented out at the minute, which will throttle the display update, the frame rate update, to like slow it down a bit. And the reason I'm doing that is that when I come to run games, they're probably going to run too fast, because like I showed earlier, it runs this ZX81 ROM on this computer runs so much faster than it would on the ZX81 itself, that I'm going to probably need to throttle the actual CPU when it comes to game playing, but not throttle it when it comes to doing other programming stuff, so that you get the full benefit of it running fast. And then the first thing to do is to check in the ZX81 registers. There's an address which is the start of the memory for the display memory, and what I do is I add 33 times 24, so there's 24 lines on the display, and there's 32 characters across, but then at the end of each line there's a halt character which the hardware uses to detect when it's at the end of a scan line. So if I add 33 times 24 to the actual address of the display in memory, I look at the last character in the display memory. So I've added that to that, and then I look at the actual character. I get the character from that address into the accumulator. I check to see if it's character 76 in hex, because character 76 hex is the halt character. So I can tell if the halt character is present that the actual ZX81 has booted up and is running, and I do that so that when the actual, because the ZX81 checks its memory, 16K of memory when it starts up, so it can take a couple of seconds to actually start the actual ZX81 itself. I don't want to be displaying stuff which is junk on the screen meanwhile, so I check to see when the actual display memory is there, has been initialized, and if it hasn't been initialized, then I change the colors, the color scheme of the Texas Instrument chip to look like it's in ZX81 fast mode, like a grey screen, and I tell it to select that color scheme by sending that to the Texas Instrument chip, and then I quit the non-maskable interrupts routine until it gets to here on a call to the non-maskable interrupt routine where the actual display is fully present, and from then on it should be able to display the display. So when it does that, so at this booted label, what I do is I set a flag in, so I've got in my actual code to actually do the display drivers and whatever I need to do for the ZX81, running the ZX81 ROM. I've got a set of flags, and I just set a flag to say okay, it's started, because what I can do in this insert in here, so any kind of initialization stuff I want to do the first time this runs, and then because it's flagged that it's run before, it will only run that code once, but at the minute I don't need to do anything in there. And just here I've got loads of lines of code which happen on each frame, and this is just debug code, so I've commented that they're all commented out of it, but I've left them in there so that for future reference, if I need to debug anything, then I can do certain things. So I've got like written some terminal sort of code which outputs characters and stuff, and on this particular thing I was looking at the keyboard port on the ZX81, and just for debugging when I was getting the keyboard running on the computer, and I was outputting values, the scan codes that I was getting back in hex on the display so that I could see what they were. So that's really neat that once you actually get the ROM running on the computer, you can actually output debug stuff which actually reads properly on the display. It really helps get things up and going. And because we're actually displaying display now, I'm changing the color palette to whatever the color palette which I want. So at the minute I'm doing black and white, so a white background with a black cursor, which is kind of what you would have seen when you're running ZX81s in the past. But because it's the Texas Instrument display, you can have basically several palettes defined in memory, and you can switch between them just instantly. So in future, I might have a configuration screen where you can select like a green screen or a different color scheme, or white on black, or something like that. And then this is where I come to actually do the actual update of the display. So I've got a function which is VRAM home. So this is Texas Instrument video RAM, and it sets the pointer in register in the Texas Instrument chip to point at the very first byte of the character RAM in the Texas Instrument chip, because I'm about to send it characters. And I get the pointer to the first byte of ZX81 display memory. So there's the first character in the display memory for ZX81. This is the output port which is on the computer, which references the Texas Instrument chip for the data. So you've got a command register and a data register, and this is the port to send the data to. And I'm going to send 24 lines of data and 32 characters per line, because I'm not going to be sending the whole code, because that would just look like junk on the screen if I try and do that. And then what I do is, first of all, I increment past the first byte of display memory, because the first byte of display memory is going to be a halt command, so I don't want to send that. And then I use this command, which is on the the Z80, and what it does is it does a repetitive output. So a single command, you can say do loads of outputs for me, and what the IR command does is it uses the HL register as a source of data, so it will read the bytes from this location. It uses the C register as the output port that's going to output that data on, and it's going to use the B register as a counter to say I'm going to output 32 bytes on this particular port. And that is extremely powerful, one of the extremely powerful instructions on the Z80. So you hear people talk about other processors, and they'll say how Z80 is slow and how their processor is fast, but actually this is extremely fast, because it reads the instruction once, and so that's the memory done for reading the instruction. Then the only time it reads memory is to read each byte of data from memory. So it doesn't have to. So if you were to write this in several commands, if you didn't have this command and you had to do it in several commands, you'd have to read memory to read the instruction load HL, or the data from HL, and then you'd have to read, say, okay, which port am I sending it to, and then you'd have to actually do the output of that port. Then you'd have to read memory to do the command increment HL. Then you'd have to read memory to do the command decrement B and jump if not 0. So you've got all those memory commands reading that you don't have to do for 32 iterations of in this particular case of the command. So when people say ZX81, the Z80 is slow, it's really not. There's some commands which are extremely powerful and extremely fast, and as well as output commands, there's memory moving commands. So if you need to move a chunk of memory, there's commands to do that which are extremely fast as well, and also searching memory. Anyhow, so next I decrement the line number which I'm on, because D holds the line count, and I do 24 lines of outputs. So that all occurs extremely fast, and that's updated the display. Whereas if it was in hardware, the hardware actually stops the computer for a lot of time, and the computer on the ZX81 doesn't get much time to actually run actual programs. Whereas in this case, as you've seen, it runs a lot quicker if you've got a Texas Instrument display chip to actually do. And then I do an output to a read from the status register of the Texas Instrument chip. And what that does is it clears the interrupt flag, which means that next time it has a frame for me to display, it will send another interrupt. If I don't do this, then it won't send any more interrupts and you won't get any updates on the display. So that's necessary to do actually that command. And then I tell it I'm no longer in the non-maskable interrupt routine, and I come back out, and the ZX81 ROM can continue with whatever it needs to do.